Hello students, welcome to another episode of Energy Chapter for Class 7 Physics. We have so far covered the different types of energies. We have learned about potential and kinetic energy. Today we are going to talk about conservation of energy. Now when we talk about conservation of energy, children, you need to remember that conservation of energy and energy conservation are not the same thing. Like when we talk about the law of conservation of energy, it states that energy cannot be created nor it can be destroyed, but it can be converted from one form to another form. And you have seen some changes before as well. Now when we are talking about a closed system, the energy, that is the amount of energy, remains fixed. Now you might be wondering, what is a closed system? It is a system which does not interact with the environment. It is closed in itself. In all the examples of energy transformation, you will see that the total energy of the system remains conserved. Now, energy conservation, when we talk about, these are the ways by which you can conserve energy. Like we ask people to switch off the lights when they are not in use, and such things that we do to protect the environment, to save the energy, right? Also, for example, if I tell you that suppose you have a mixer at your home which is using the electrical energy, and it might not be consuming the full energy because some of the energy is lost in producing the sound mixer, and also the total energy will remain however same. So let us see some examples to understand how the law of conservation of energy is followed in physics. Now in this you can see the motion of a simple pendulum. You know there is a suspension where the pendulum is hanging. This is a bob. This is the mean position of your pendulum. But when I take it and leave it, it starts moving to and fro. So these positions where maximum rise is happening of the bob is called the extreme position. Now you need to remember that when I take the bob and raise it to a certain height, the potential energy becomes maximum and the kinetic energy is zero because it is just raised to a particular height. And when I leave the bob, it starts moving. So when it comes down, the kinetic energy is the maximum, that is E, that is the total energy for example, and potential energy is zero. And when it reaches to the other extreme position, the kinetic energy again becomes zero and the potential energy becomes the maximum. So here you can see that the energy is becoming zero maximum, but the overall energy of the system remains the same. And you also know that the pendulum will not oscillate indefinitely. It will stop after certain time because of the friction of the medium, and the energy of the pendulum is dissipated, we can say, to the molecules of the medium, and slowly the pendulum again comes to its mean position. The next example that we talk about is a roller coaster. You all might have sat in the roller coasters, and you know it is a bumpy ride of ups and downs. So in this system, the total mechanical energy, that is the sum of the potential and the kinetic energy, is going to remain constant. However, you know that there will be loss of energy due to friction. So when it is at a particular height, suppose A, the potential energy becomes maximum and kinetic energy is zero. But as it moves down and comes to position B, the kinetic energy is maximum and the potential energy has become zero because of the height. Less height. And then as it goes up again to a medium position, it is potential energy is suppose E1 and kinetic energy is E minus E1. So here E is the total energy. So you can see how the energy is being converted from one form to another, but the overall energy somewhat remains the same. Obviously some energy is also lost because of the heat, because of the friction. Let us try to understand about boiling water in a kettle. So when we are boiling water in a kettle, you know that a kettle works with the electrical energy. So obviously when the coil gets the electrical energy, it starts getting heated up and thus in turn heats the water. So when the water is heated, it changes into steam. So if you see, the overall energy it is again the energy, the total electrical energy which is lost by the electrical supply is equal to the energy which is gained by the water. And even though this is not a complete closed system, you can see that the energy gained and lost are more or less same. Let us see one more example where we can see a car being pushed uphill. So when a person is pushing a car uphill, he is doing work. He is doing work against the gravity. So this energy which the man is using to push his car uphill, the energy which is gained by the car is actually the energy which is lost by the person in the form of his energy. And also if you see that the energy lost by us is equal to the work which is done against the gravity. So energy gained by the car will be the same as the work done by the car. And you can say that here neither the energy is being lost nor the energy is being gained. So overall energy, if we are speaking about here, the potential energy which is stored by the car is equal to the fuel stored in our body. Means how much energy we are having, we are able to push the car with that much of energy. So our energy is getting converted into the energy to convert the car or to push the car uphill. With these simple examples, I hope I am able to tell you how the energy conservation or the law of energy conservation is applied and how the energy from one form is changed to the other form. You can try giving me more examples in the comment section. Thank you for watching.